10th Standard Science, Chapter 3, Thermal Physics. The lesson or book back answers purple. First Roman letter, choose the correct answer. First one, the value of universal gas constant. Option D answer, 8.31 mole minus 1, Kelvin minus 1. Second one, if a substance is heated or cooled, the change in mass of the substance is, option C answer, 0. Third one, if a substance is heated or cooled, the linear expansion occurs along the axis of, option C, both A and B. Fourth one, temperature is the average dash of the molecules of a substance. Option C answer, difference in TE and PE. Fifth one, in the given diagram, the possible directions of heat energy transformation is, option A answer. Roman letter 2, fill in the blanks. First one, the value of Avogadro number dash 6.023 into 10 to the power of 23 bar mole or mole minus 1. Second one, the temperature and heat or dash quantities, scalar quantities. Third question, 1 calorie is the amount of heat energy required to rise the temperature of 1 gram of water through 1 degree Celsius. Fourth question, according to Boyle's law, the shape of the graph between pressure and reciprocal of volume is dash, answer straight line. Third Roman letter, state whether the following statement are true or false. If false, explain why. First one, for a given heat in liquid, the apparent expansion is more than that of real expansion. The statement is false. The real expansion is more or less than that of apparent expansion. Second one, thermal energy always flows from a system of higher temperature to a system at lower temperature. The statement is true. Third one, according to Charles' law, at a constant pressure, the temperature is inversely proportional to volume. The statement is false. The correct statement, volume is directly proportional to temperature at a constant pressure. Fourth Roman letter, match the items in column 1 to the items in column 2. First one, linear expansion, answer change in length. Second one, superficial expansion, change in area. Third one, cubical expansion, change in volume. Fourth one, heat transformation, hot body to cold body. Fifth one, Boltzmann constant, answer 1.381 into 10 to the power of minus 23 Joule Kelvin minus 1. Fifth Roman letter, assertion and reason type questions. First one, assertion. There is no effects on the other and when one end of the rod is only heated. Reason, heat always flows from a region of lower temperature to higher temperature of the rod. Answer, option A. Both the assertion and the reason are true and the reason is the correct explanation of the assertion. Second one, assertion. Gas is highly compressible than solid and liquid. Then reason, interatomic or intermolecular distance in the gas is comparably high. Answer, option C. Assertion is true but the reason is false. Sixth Roman letter, answer in briefly. First one, define 1 calorie. 1 calorie is the amount of heat required to rise the temperature of 1 gram of water through 1 degree Celsius. Second question, distinguish between linear, aerial and superficial expansion. First one, linear expansion. First point, also called longitudinal expansion. Second one, in the formula எழுதிக்கங்க. Then aerial expansion and superficial expansion. First point, also called as superficial expansion. Second one, also write this formula. Third question, what is coefficient of cubical expansion? Answer, the ratio increased in volume of the body per degree rise in temperature to its unit volume is called as coefficient of cubical expansion. Its unit is K minus 1. Fourth question, state Boyle's law. When the temperature is kept constant, the volume of a fixed mass of gas is inversely proportional to its pressure. Then P 1 by V, PV is equal to constant. Fifth question, state the law of volume. According to this law, when the pressure of a gas is kept constant, the volume of a gas is directly proportional to the temperature of the gas. Sixth question, distinguish between ideal gas and real gas. First one, ideal gas. First point, if the atom or molecule of a gas do not interact with each other, then the gas is said to be an ideal gas or a perfect gas. Second point, ideal gas does not have volume. Next one, real gas. First point, if the molecules or atoms of a gas interact with each other with a definite amount of intermolecular or interatomic force of attraction, then the gas is said to be a real gas. Second point, real gas has volume. Seventh question, what is coefficient of real expansion? The ratio of a true rise in the volume of the liquid to unit original volume when the temperature rises by 1 Kelvin is called as coefficient of real expansion. Its SI unit is per K or K minus 1. Eighth question, what is coefficient of apparent expansion? Coefficient of apparent expansion is defined as the ratio of the apparent rise in the volume of the liquid per degree rise in temperature to its unit volume. The SI unit of coefficient of apparent expansion is K minus 1. Seventh Roman letter, numerical problems. First one, find the final temperature of a copper rod whose area of cross section changes from 10 m squared to 11 m squared due to heating. The copper rod is initially kept at 90 K. Coefficient of superficial expansion is 0.0021 bar K. Given area of copper rod A is equal to 10 m power 2, after expansion A2 is equal to 11 m squared. Initially, temperature T1 is equal to 90 K. Coefficient of superphysical expansion is equal to 0.0021 slash K. To find final temperature, T is equal to what? Write the solutions in your classwork note. Copy down these problems. 8th Roman letter, answer in detail. First one, derive the ideal gas equation. Answer, first point, the ideal gas equation is an equation which relates all the properties of an ideal gas such as pressure P, volume V, temperature T and the amount of the gas. Second point, an ideal gas obeys Boyle's law and Charles' law and Avogadro's law. Third point, according to Boyle's law, PV is equal to constant. Fourth point, according to Charles' law, V by T is equal to constant. Fifth point, according to Avogadro's law, V by N is equal to constant. Sixth point, after combining equations 1, 2 and 3, we can write the following equations. PV bar NT is equal to constant. The above relation is called the combined gas law. Then seventh point, if we consider a gas which contains mu moles of a gas, the number of atoms contained will be equal to mu time the Avogadro number Na. Example, N is equal to mu Na. Eighth point, using this value equation, 4 can be written as PV mu NAT is equal to constant. Then ninth Roman letter, the value of constant in the above equation is taken to be Kb, which is called as Boltzmann's constant. Its value is 1.381 into 10 to the power of minus 23 Joule Kelvin minus 1. 10th point, hence we have the following equations, then write this equation. 11th point, here mu Na Kb is equal to R, which is termed as universal gas constant, whose value is 8.31. Z mole minus 1 Kelvin minus 1 PV is equal to RT. This is called the ideal gas equation. Second question, explain the experiment of measuring the real and apparent expansion of a liquid with any diagram. First point, the liquid whose real and apparent expansion is to be determined is poured in a container up to a level. Mark this level as L1. Second point, now heat the container and the liquid using the burner. Initially, the container receives the thermal energy and it expands. Third point, as a result, the volume of the liquid appears to have reduced. Mark this reduced level of a liquid as L2. Fourth point, on further heating, the thermal energy is supplied to the liquid, resulting in the expansion of the liquid. Hence, the level of liquid rises to L3. Fifth point, now the difference between the level L1 and L3 is called as apparent expansion, and the difference between the level L2 and L3 is called real expansion. Then sixth point, the real expansion is always more than the apparent expansion. You may draw this picture and label the parts. Then seventh point, real expansion is equal to L3 minus L2, apparent expansion is equal to L3 minus L1. Ninth Roman letter hearts question. If you keep ice at 0 degrees Celsius and water at 0 degrees Celsius in either of your hands, in which hand you will feel more chillness? Why? We will feel more chillness in the hand ice is placed at 0 degrees Celsius. Latent heat absorbed by the ice is greater than that absorbed by water. Reason, the latent heat of vaporization absorbed by the ice is greater than water at the same temperature. Then draw this one.